Question number 6. Whoa. I bet when you see this problem at first you probably be like, okay, next. But I guarantee you that it's a lot simpler than what it looks. It's entirely about quadratic functions and vertex form. So let's go ahead and then read it first carefully and then figure out what they are asking us. What are we trying to find here? It looks like a nice bridge, by the way. The towers of a suspension bridge are 800 feet apart. So from here to here is 800 feet apart and rises about 162 feet higher than the road. So if this is a road, it's about 162 feet higher than the road. Suppose the cable between the two towers has the shape of a parabola, which looks like a wider parabola. So the leading coefficient is going to be a really small one because it's wide. And it is 2 feet higher than the road. So this is from here to here is going to be 2 feet and halfway between the road. So right here. So right through the center. The question is, what is the approximate height of the cable 120 feet away from either towers? It can be either from this to here when it is 120 feet or from here to here. So the first thing that we need to do is basically we need to figure out what 120 feet means from our axis, because we haven't drawn it yet, because we can draw it at different places. We could draw it right here, we could draw it right here, we could draw it in the center. So ideally the center would be much more easier in this case. So, and also depending on where our x-axis is gonna be, our answer might be negative or positive. So we have to change it into positive ultimately, depending on where we choose our axis. So for me, I'm gonna go ahead and then use the center as a y-axis, the center of this suspension curve. So I'm gonna go ahead and then divide this whole thing in half. So this would be my y. Okay, so when it says 120 feet, now I know it is from here to here, it has to be 120 feet. And then I'm going to go ahead and then do my x right on at the top of the two suspension bridge. I'm trying to do as straight as possible. So this is my x-axis, that's my y-axis. Now based on this, they are asking us the height 120 feet away from either of the end of the tower, either towers. So I'm gonna go ahead and then assume this is 120. Now since this is 800, the middle one is gonna split it into two 400. So the coordinate of this point is gonna be 400, 0 because I'm on the x-axis, and then this one is gonna be negative 400, 0. And 120 feet away from that is going to give us this point. If you subtract 120 from 400, you get 280. So our x is actually 280, and then we're looking for the height at this point. So if I draw this, so we're looking for that coordinate. This is going to be 280, something. Now how are we going to find that one? Well, we just need an equation of this parabola. I'm going to go ahead and then decide the vertex is going to be right here, and you know it is on the y-axis, so the x coordinate is going to be 0, and then the y coordinate is going to be negative 160 because it is 2 feet above the road. Don't forget that one right here. So these are my h and k. So let's go ahead and then use the vertex form to write this equation, okay? And then we're going to get something much more simple. Alright, now the first thing that I'm going to do is the vertex form. If you remember, y equals a times x minus h the whole square plus k. Now y equals, we don't know what our a is, that's going to be the tricky one, but we're going to fix it soon. X minus our x coordinate of the vertex is 0 right here, so 0 the whole square plus our y coordinate is going to be negative 160, and then this is 0. So when we simplify this, we get something like y equals ax squared minus 160. The only thing left here is to find what a is. Remember, we do know one point on this curve, which is this point or that point. We can either use this x or y. So let's go ahead and then use 400 0. I'm going to use 400 comma 0, and 400 is going to be x, y is going to be 0. So when I plug that, I get 0 is equals to a times x is going to be 400 the whole square minus 160. Now I can add 160 to both sides, and then I get a times 400 squared is gonna be 16,1,2,3,0. So 160,000 is equals to 160. So all what I did is I squared the 400 and I got this, and I took the negative 160 to the other side. Now if I divide both sides by 160,000, I'm gonna get this 0 cancels out with this 0 by 16, 1 by 16, 1, and then I got 3 zeros. So our A is gonna be 1 in 1,000. Perfect. Now I'm gonna plug it back into our original equation, which was y equals ax squared minus 160, and then this becomes 1 in 1,000 x squared minus 160. This is what I mean by our A is really small, because it's the curve, the suspension looks really wide. Now the last step is to plug this back, or to find the y coordinate when x is 280. So I'm going to plug x 280, and then I get y equals 1 in 1,000 times 280 square minus 160. I'm running out of space, so I'm going to come right here. Y equals, when you do the maths here, you're going to get 280 square. It's going to be a really big number. That's going to be 78,400, and then we're going to divide that by 1,000, and then I get 78.4. So this becomes 78.4 minus 160. This is what I mean by it's going to be a negative answer. So when we subtract 160 from there, we get 81, negative 81.6. This is a y coordinate. Now why did I get a negative? Well, if you look back my grid, this coordinate is going to be under the x-axis, so this is going to be negative 81.6. So approximately we are 80 feet under the tower. So the height of the suspension bridge 120 feet away from either of the two vertices, the two towers, is going to be about 80 feet below. So the correct answer is 80. I told you it was going to be a piece of cake. Alright, this completes this problem.